Okay, so this is 1-7, computing scientific notation. Feel free to abbreviate. Computing scientific notation. What does it mean to compute? What?
Like reading or like processing?
Processing, you think of computers? Who else knows what compute means in math? Nobody? What, Ryan? Okay. Right? Maybe finding what it's equal to? So computing has to do with solving. So that's what we're going to do. We're going to figure out how do we solve these if we have to add, subtract, multiply, and divide them. Okay? There's some tricks to these. There's two ways. I'm going to show you one and tell you about the other. Just depends what kind of calculator you have. If you have a pretty good calculator, you can use it. If your calculator's not so good, then you have to do this the long way. That'll work. Okay, so for multiplying and dividing, see I breathed a lot here. Multiplying and dividing with scientific notation, you're going to use the product of powers and quotient of powers rules to multiply and divide numbers. So we learned products, power to a power, and we learned divide to subtract, remember? You're going to use them. So use the product of powers and quotient means divide, of powers, rules, to multiply and divide numbers written in scientific notation. That's what we're doing. Okay, here's an example. This is an example of product, right? We're multiplying. So we're multiplying this number, and raise your hand if you think it's going to be a large number. Raise your hand if you think it's going to be a small number. Raise your hand if you don't know. All right. It's going to be a large number. So this is what we do, and these are kind of in steps. So we have 7.2 times 10 cubed times 1.6 times 10 to the fourth. So step 1 is to separate the numbers and separate the tens, because these are the same base, so we can do this. This is called the commutative property. When we multiply, we can move things around. Commuters move, right? Remember that? Okay. And then, after we've separated the two, we can multiply the numbers, and then what should we do over here for the exponents? When you multiply exponents, you add them. Good. So here I have 11.52. That's what these two make in your calculator. Times 10, 3 plus 4 is 7. And you're not quite finished, because in order for it to be correctly written in scientific notation, you have to move the decimal place. So I'm going to move it one place over to the left so that it's between those first two digits. So if I move it one place to the left, I need to add. See, this is 10 to the 7th. I need to make it 10 to the 8th now. I moved one more place, so I have to add one here. What if I move 2 places?
Or the 10th.
It'd be to the 10th. Yes.
Why did you have to move the decimal point?
Because the decimal point in scientific notation must be between the first 2 numbers. Yeah. So if I had to move 2 more, it'd be a 10. If I kept going and say I moved 10 more, you just keep adding 1 to each exponent. Okay. Yes, Ryan.
I need to figure out the 10 to the third was 1 by 6.
Was this?
No, 10 to the third at the very top.
Oh, so you take the numbers and put them here together. You commute them, right? Commutative. And you take the exponents and you put them here.
Oh.
Good question. Okay, let's do another one. They're a little bit challenging. Oh, does anyone see another way you could figure this out without using it this way? Could you put all these back into standard form? Multiply those big numbers and then put it back into scientific notation?
Wouldn't that be a lot slower than that?
It would be slower, but you could do it that way. So the reason we do this is it makes it easier to compute very large numbers. Okay, when we have very large numbers, it's easier to compute them this way. Computers do this though, right? Yeah. Okay. Example 2. Here's division. So the first one was multiplication, now we have division. So we have 7 times 10 to the 9th over 3 times 10 to the 8th. So again, we separate the numbers. Do you see it, Ryan?
Yeah.
Okay, good. So I separate the 7/3 and separate the exponents, the tens with the exponents. And 7 divided by 3 is approximately, these little things mean approximately, 2.3. And then when you divide, remember you subtract, so that's 10 to the 9 minus 8, which is just 10 to the 1. Any questions on these two? So you're using what you just learned about multiplying means you add and dividing means you subtract. But you can use that to compute these. Again, if you can't remember how to do this, you could multiply this out and figure out what big number this is, punch it in your calculator, divide it by whatever big number this is, and then you could get that at the end. Okay? So addition and subtraction, we're going to move on to that. Addition and subtraction with scientific notation. So we just did multiply, divide, now we're going to learn how to add and subtract. 2 more examples. All right. So you must line up the place values represented by the exponent, and I'm going to show you what that means. If you don't do this first, you'll get it wrong, which is what happens on the test. People forget to do this. So you must line up the place values represented by the exponent. Here's an example of what I'm talking about. So I have 6.89 times 10 to the 4th plus 9.24 times 10 to the 5th. My place values are the exponents. Are they the same? No, this is not a trick question. Is 4 the same as 5? No. So we have to fix that. How do you think, raise your hand if you think you can tell me how to fix it. How to make this 5 into a 4. What?
Move the decimal.
Perfect. Move the decimal. You're getting it. So when you move the decimal, this first one can stay the same. But I move the decimal over one place to the right to make this a 4. It's kind of like you're working backwards. So you notice you're going to match the exponent with the lowest number. You're not going to go this way because then you have to go 0.0, right? Go this way to the right. This is very tricky for some people. It will take some practice. I should say for most people it's very tricky. So now I can add these. So I add the numbers. 6.89 plus 92.4. I keep this times 10 to the 4th on the outside. When I add these, I get 99.29, but I need to move the decimal again back to the place between the first two numbers. So if I'm going back one place, what is this exponent going to be? Someone else know besides Jared? What is it going to be?
10 cubed.
Going back, going to the left, so it will be 10 to the 5th. You were thinking the opposite way. So first, you have to move the decimal this way to get it a 4, and then you're going to go back that way to make it back to a 5. Could you do this the long way? Yes. But you have to figure out what big number this is, like 689,000. Add it to 9,240,000, and then work backwards. But you can do that. So if you can't remember this method, at least you know you have a second method. Okay, one last example, example 4, and then we're finished with notes for today. Everyone got that down okay? Okay, the very last thing, well that was adding, so now we need a subtraction one. Do you think that subtraction is the same?
Kind of.
Kind of is, yeah. Kind of the same. Still the same method. But I want to show you, sometimes you'll get one number that's in scientific notation, and you'll get one number that's in standard form. So that's like an extra step. So either you turn this one into standard form and subtract and then go backwards, or you could turn this one into scientific notation. Either method is fine with me. A lot of people prefer to turn this into a standard number if you get one like this, because it's easier, isn't it? But I will show you this way first. So this is 7.83 times 10 to the 8th minus $11,610,000, Jared's future salary, right, Jared? So I'm going to change this one into scientific notation. It's a little more challenging this way, but I want you to see it. So I have 1.161 times 10 to the 7th. So all I did was I moved this 7 places back, right? The decimal point. There's 7 places. Or you could count the numbers. 1, 2, 3, 4, 5, 6, 7. Now what do I have to do? I have an 8 and a 7. What should I do? Should I make this one a 7 or make that one an 8? 7? Good. So I'm going to turn that one into a 7. So I move the decimal over 1 place. See right here it was 7.83. Now it's 78.3. Change that to a 7. Now I can subtract the numbers. 78.3, 1.161. So I separate the numbers out. I'm just showing you all the steps, but you don't necessarily have to write them all unless you need it. So 78.3 minus 1.161, punch that in your calculator, and you should get 77.139, but we have to move the decimal again.
I don't understand is why you have 2 10 to the 7, but you got rid of 1.
Up here I had an 8 and a 7.
Yeah, but then you change that one to 7, and then you come down here and that's gone. How did that disappear?
This 7?
Yeah, no, that 10 to the 7 is just
It's
gone.
over here now.
But there's 2 of them right there. But
Yeah, because you're just combining the numbers, and then this is just on the outside here. So you'll see, when you multiply it out, it works out. You'll see why. Because you're combining numbers, right? You're subtracting the numbers. But the base 10 doesn't change. The exponent might change, but the base 10 doesn't change. Good questions. So here I have to move this back a place to the left. So this will be... this 7 right here will become what? If I go to the left, what will it become? Say it. Not negative. Raise your hand if you say 6. Raise your hand if you say 8. 8's the winner. So to the left, the number gets bigger. To the right, the number gets smaller. Move to the left, bigger number. This takes practice.